And then we also found species-specific responses to these treatments across things like both the survivorship, the growth, and then how much they grew over time. And then to answer my question, can we grow red and white mangroves in crushed glass and sargassum mixtures? The answer is yes. However, the caveat is that the white mangroves are not so happy. And so suggestions could be to have more shade, to have pest exclusion from those pesky caterpillars, and then to grow them in different mixtures of fresh water. And to just show that white mangroves require different growing conditions than the red mangroves. And we did them the same because we wanted to be able to compare across these species to see if we could then use these different substrates to grow these mangroves. And what these research also showed us that bigger plants did better, and that the soil grew bigger, faster, and survived more across these different substrates. So for my limitations, first one we had was that it was only a 6-month study. So because I focused on early establishment, it reflected that 6-month study rather than the long-term field outcomes. And because it was conducted in controlled tanks, these treatment effects that we observed may shift based on them going out into the real world and be exposed to coastal conditions. And then, like I mentioned, because both species were grown under the same conditions, it's useful for comparison purposes, but not so much for the actual growth of these white mangroves. And then we also saw some compaction and decomposition in the sargassum mixes over time, which influenced potentially the aeration in the pot, so dissolved oxygen, as well as nutrient release. So we had that massive compaction, and some plants actually had nothing at the end of the experiment. So another thing we could potentially do is, potentially add more sargassum throughout the experiment. And then, like I mentioned, the biomass, we put drying in the large bags, and that led to these negative values. So I had to reduce the amount of samples I had for comparisons. These limitations overall help to define where findings can actually be applied, as well as to support clear next steps for future field trials. So while they tell us how each substrate affects early establishment in an energy setting, the next step is to test how these plants would actually grow out in the field. And so some future work that could be done would be to do field trials, because in an extension of the Holderbolt 2023 paper, where she grew mangroves in those soil and glass mixtures, found that there was a significant difference across, not a significant difference across the survivorship when they were growing in the field, but that their growth patterns of how well they were growing did not close. So they still stayed glass doing worse than the soil. We want to see if that could also happen for my plants as well. And then to test their microbial patterns across these different substrates, especially the sargassum, to see what's in there. And then to do a test of how much sargassum you can add until it becomes bad for the plants. Then we would do a study, potentially, of minimally processing the sargassum, as well as maybe using the soil plus that fresh sargassum as another substrate, because that would help to reduce the amount of cost in terms of the potting soil. And then finally, the final main goal of this entire thing is to see if we could potentially scale up this process at something that's scalable and low cost, because we're out in nurseries and we need to keep our costs low and our restoration high. So thank you so much to everyone that made this possible, for my committee members for being with me from the beginning to the end of the study, as well as all the volunteers that helped to make the collection, processing, monitoring, and sacrificing possible. A special thanks to Dr. Stanford for allowing her students to get extra credit to monitor my plants, as well as to Jeremiah, Wando, and Joe Townsend for helping me with that stats a lot. And yeah, thank you so much. Sorry.
Any questions from the audience or online?
Let's see.
Tell me a little bit about the statistical techniques that you used.
Yeah, so I used the mixtures of ANOVAs and the critical also testing for whether the data was normal and homogeneous. And then I did a lot of linear regressions to compare these different metrics as well.
Some post-hoc tests?
Yes, I did the post-hoc to get those numbers, those significant letters. It was the Wilcox as well as the Dunn-Home test as well. And that was just based on whether that site factor was also significant as well. So that was also included in these metrics as well. Let me also yeah. Hi, Shelby.
Okay, amazing job.
Thank you.
I might have missed this, or when you were talking about how like the sarcasm in the plots kind of decrease over time.
Mhm.
Did you have any ideas for like, do you think maybe it dried up or it was starting to decompose?
So did you already question. So Shelby asked about the sarcasm and whether or not it decomposed over time or if it dried up, and it definitely decomposed. So whenever we'd be doing monitoring, we would lift the pot up and just brown liquid like right below it, which shows that it broke down steadily across those months. And so that's why I wanted to see if we added more sarcasm, if that would potentially benefit them to have something to actually stay in. Hi, Sean.
So when the sarcasm started degrading, you had like changes. I didn't know if you mentioned it in any of your stats, but like do you see any like with the growth rates over the time that they were decomposing?
Not entirely sure, that's the thing. So because the question is if all growth patterns.
How could you have done that?
That's a good question. How could I have tested for that? Let's see. Let's see. I'm not sure.